Welcome everyone. It is my third video lecture on 6-step voltage source inverter. Here I will explain how to simulate the 6-step inverter using PSIM software. We know that PSIM is a well-known simulation software that is especially designed for the power electronic circuits. So you may feel some user-friendly interface on this platform, and if you are using the switches like MOSFET means you can specify the type of MOSFET. That means either you are using N MOSFET or P MOSFET. If you are using the transistor as a switching element means you can specify whether it is NPN or PNP. And by the way of sources, you can specify the type of voltage source. That may be the sine waveform, triangular waveform, and sawtooth waveform. Likewise, so the controlling sense is all up to our hand. So we can simulate our circuit with higher accuracy. So you can access the tools from this shortcut toolbar. You may access the ground and the elements like resistors, inductors, capacitors, and the switches like diode, SCRs, and IGBTs, MOSFETs from here. You may take some measurement devices from here also, voltage probe and the current probes. And you may take some DC voltage source, AC voltage source from this shortcut toolbar. So let our circuit is having 6 MOSFET switches. So take 6 MOSFET switches from the shortcut toolbar and place it over here. Use the grid lines for placing the blocks. Then take the DC voltage source, and with the help of the pen tool you may connect the components. This pen tool providing the wire connection. It is useful to connect the components as per our circuit diagram. So okay, give the name for each MOSFET switches. So it is MOSFET 1, it is MOSFET 2. If you click on the display column, the name of the MOSFET will be displayed near the switches. So it is MOSFET 3, it is MOSFET 4, and MOSFET 5 is here. Finally the MOSFET 6 is here. Just click on the DC voltage source, it is VDC, and I am setting the DC input as 24 volt. Okay. Now, sorry. Now the remaining work is providing the gate pulses. So please take the gating block from here and connect it to each gate terminal. Fine. So if you double click on it, the name is G1, that means the gate pulse 1. Just displayed it here, and it is gate 2, and it is gate 3, it is gate 4, and it is gate 5. Finally it is gate 6. Okay. Then I am taking 3-phase output from here. So I am connecting the 3 resistive loads. With the help of this pen tool, I am connecting the 3-phase to the 3 resistive elements, and I am setting the output terminal as star topology. So the neutral is here grounded for making the balance condition. Take the voltage probe and place it over here. I am taking 3 different voltage probes here for measuring 3 phase voltages. So phase voltage is nothing but voltage between the phase and the neutral. Here 3 phase voltages are measured with the help of 3 voltage probes. Double click on it the name will be VP1, phase voltage 1, and the phase voltage 2, and the phase voltage 3. I am setting the default resistance value as 12 ohm. Let's change the parameters for the gating blocks. Okay, this gating block 1. PSIM requires 3 parameters has to be changed for the gating blocks. First one is frequency, the next one is number of points, the third one is switching points. Frequency. The gate pulse frequency is a only parameter that designing the output frequency. Here 5000, that means 5 kHz is a default frequency, gate frequency. If you are setting it as 5 kHz means the output frequency will be in the range of 5 kHz. Okay, I am going to simulate the inverter for obtaining the 50 Hz frequency. So I need to change the gate pulse frequency as 50 Hz. So make it very clear that each and every gate pulses have to be in the same frequency level. So I am changing the frequency of all gate pulses as 50 Hz. So frequency of the output waveform will be in 50 Hz range. Second one is, go to the gating block 1. Second one is number of points. So let me see the pulse diagram. Here I will simulate the 180-degree conduction mode, and this the gate pulse for gate pulse diagram for gate pulse 1. It is starting from here and ended up to 360th degree. Please take one gate pulse diagram. The number of points, which means the number of points actually refers that at which the gate pulse turn on period is happened, which means it is the first point and it is the second point. In between these 2 points only the turn on period will be appear. For a single gate pulse, 2 points, that is balancing the turn on time. Number 1, number 2, first point and the second point. For a next gate pulse, the first point and second point. So the number of points refers that the number of points that balancing the number of the turn on time of the gate pulse. So you may verify it. All the gate pulses are having the number of points as 2. Okay. For a single waveform, for a single gate pulse 2, the number of points is 2. 1, 2. Likewise, you may check it out in the gate pulse 3 also. Number 1, number 2. So set the number of points as 2. By default, the number of values is 2. So keep it as the same value. And the second one is switching point. Switching point. The switching point is nothing but where it is switched on and where it is switched off. So the gate pulse 1 is switched on at 0 degree electrical angle and it is switched off at 180 degree electrical angle. So give it as 0 space 180 degree. The gate pulse 2, that is switched on at 60th degree electrical angle and 240th degree electrical angle, it is switched off. So give it as 60 space 240. Okay. So gate pulse 3 is 120 to 300. So gate pulse 3 is 300. 120 to 300. The next one is 180 to 360. Gate blocks 4 is 180 to 360. The gate blocks 5 is 240 to 420. So 240 to 420. Finally, the gate pulse 6 is switched on at 300th degree and it is switched off at 480th degree. So 300 space 480. Okay. So the parameter feeding is almost over, and go to the simulate option and simulation control. You will get the timer on your cursor, and time step is, I'm setting it as 5 microseconds, and I'm setting the total time as 1 second. Just click on this button. Just it is run simulation. After running, you may take the three phase voltages into the single display. Here I will simulate. Here I will display you only the one phase voltage, that is VP1, first phase voltage. With the waveforms will be in the sim view window. Here you can see the 6-step output. So it is one complete modified sine waveform. Step 1, step 2, step 3, 4 and 5 and 6 is 6-step output, and it is actually a phase voltage, and it is having 2 levels. That means first level, first step, and the second step. If you want to measure the voltage value at each instance, means you have to go to the options here, and if you click on it, the value of the amplitude will be displayed over in this measure window. I'm clicking here. That means the first step. Okay, so it is displayed as 1.59 e power 1. That means nearly 15.9. Actually, it is 16 volt. Okay, so I already set the input voltage as 24 voltage. So the first step will be the 2/3 of V input. So to 2/3 of 24 is nothing but 16 volt. So the next one is the first step value. It is nothing but 1/3 of input. That means 1/3 of 24. That is nearly to the 8 volt. Okay. So here it is displayed as 7.9. That is nearly to 8 volt. If you click on this lower first step, the magnitude will be minus 15.9. That means minus 60. Minus 2/3 of the input. If you click on the second step, means it will give the value as minus 8 volt, which means minus 1/3 of the input. So it is nothing but the 6-step output. You may add some graph. I mean, you may display the 3 phase voltages in this sim view window. So please click on the option here, and you may track some phase voltages, and you may display the second phase voltage in the same window itself. If you want to add more phase voltages, means click on the properties, select the VP3 and add to the display column. Click OK. The 3 phase voltages are providing the 6-step output. If you want to take the line voltage, means you have to set the voltage probe like this manner, which means 9 voltages, that is measuring the face-to-face voltage. Okay, so you may connect the voltage probe like this manner. Phase A to phase B, phase B to phase C, and phase C to phase A. You may rename it. It is phase A to C, and it is phase B to C, and it is phase C to A. Let's start the simulation. You can access the VAC line voltage. Let's take a look at this line voltage diagram. If you go in detail to the waveform, you can check the voltage levels, V maximum, 0 and V minimum. It is simultaneously provided by the line voltages. Just check the output voltage. It is V maximum, 24 voltage. It is 0, nearly 0. It is V minimum minus 24 voltage. So it is nothing but line voltage. Okay, so you can simulate the circuit and you can add the three line voltages in the same sim view window itself. So you can get the three line voltages in the same graph itself. So thank you for watching my video lectures. Post your comments and subscribe me to watch my upcoming videos. Have a nice day. Thank you.